Hi, this is SensorLab. Let's introduce Gearcoder, a linear encoder that uses a scale that looks like a gear. In this video, I'm not going to show you the principles or performance, but rather a video of driving a Mitsubishi linear motor with a Gearcoder. For more information, check out this video introducing Gearcoder for robots, and we'll make more videos based on linear next time. The Gearcoder is a sensor that is placed against a straight gear, like a rack of rack pins, to provide sub-micrometer resolution and absolute positioning of one tooth cycle of a gear. First, I'll set the speed at 300 mm per second and drive a total of 5 round trips. While you watch the running video, here's a quick explanation. You may be very unfamiliar with linear encoders that use gears. When using magnetic linear encoders, the scale is open, so the magnetic scale can be demagnetized, or foreign objects such as iron powder can stick to the scale, causing the linear encoder to fail. The Gearcoder we are currently demonstrating has a resolution of 0.2 micrometers. Depending on the product, the resolution will vary from 0.1, 0.2, 0.5, 1.0 micrometers. First, we'll set the speed to 500 mm per second and drive it. For serial communication, we recommend the precise Gearcoder with a resolution of 0.1 micrometers or 0.2 micrometers. The incremental output Gearcoder can be used with any resolution you want. First, we'll set the speed to 700 mm per second and drive it. Since the resolution is 0.2 micrometers, the travel distance is 1,500,000 counts, or 300 millimeters. Generate sine and cosine waves by sensing the change in tooth shape for one cycle of the tooth. It interpolates analog signals for high-precision position sensing and transmits them over serial communication. We are going to set the speed to 1 meter per second and drive it. Depending on the resolution and output method, it can be used at distances of 20 meters or more. Long-range absolute position sensing is possible with batteries for general servo motors. Let's check if the commanded speed is 1 meter per second and the actual speed is also followed at 1 meter per second. If you look at the bottom left picture, the yellow line is the speed. If you zoom in, you can see that it's tracking well. Let's set the speed to 1.2 meters per second and drive it. Similarly, let's check the actual speed against the commanded speed. It's tracking well with an actual speed of 1.2 meters per second. If you look at the actual speed, you can see that there is a lot of speed ripple compared to using a traditional optical encoder. This is because it is unloaded and therefore has less inertia, it is tuned for jog driving, and most importantly, the gear scale has a larger tooth spacing than a traditional optical scale. This characteristic is common to magnetic and inductive linear encoders, even with high resolution. Finally, we're going to set the speed to 1.5 meters per second and drive it. The 1.5 meters per second constant velocity section is too short to see, but it's tracking well. If you look closely, there are parts that jump out in the speed and torque graphs. This is where the scale is intentionally set crookedly. If you look closely at the gear type scale, you can see that it is attached crookedly. The Gearcoder is a sensor for point-to-point position control rather than precise speed control. It is suitable for applications where long travel distances are required and environmental resistance is required. To show that there is no problem during operation even if it is attached crookedly to this degree, we tested the gear scale by attaching it crookedly. In reality, there will be no need to attach it crookedly to this degree. This Gearcoder has characteristics similar to magnetic linear encoders and is suitable for applications that require performance between the motor coder and optical encoders. Next, we will prepare an introduction video on the principles and characteristics of the gear-type linear encoder, a video testing the repeatability, and a video of attaching it to a linear motor with a long travel distance and driving it at more than 3 meters per second. If you turn on notifications, it will be more convenient when you watch the next video. Thank you for watching.
The SensorLab.